Okay, for help on page 24 in the note packet, we just have 4 problems to do, all involving circles here. In number 7, we're trying to find the area of the shaded region here. Basically, we want to find the area of the entire circle and subtract these 2 triangles from it. Now, it tells us the radius is 5, and it's not just the radius here, but that distance is 5. You can calculate the area of the circle from it. But since that's the radius here, it's also the radius here, so you know that this distance is also 5. And using those 2 measurements, we can find the area of this triangle, and likewise for the area of this triangle, and subtract the 2 triangles from your total area of the circle. For problem number 8, we're going to have to do a couple things. We got 3 parts going on here. We're going to find the area of this entire circle, and we're going to subtract the area of this white part, and then we're going to add the area of this little circle and back into it. Now, the number here is missing, so I'm just going to give you some numbers for this. Let's just say that QB here is 1. And if this is 1, we can use that to find the area of this little circle. If this is 1, though, and this is the center, then that's a radius, so this side is also 1. Then, from P to B, that's the radius of the white circle, so that total radius is 2, which means from O to P is also 2. So now, if O to B is the radius of the big circle, well, 1, 2, 3, 4, that means A to O is going to have a length of 4. So what we're going to do is find the areas of these 3 circles, take the area of the big one, subtract the white one, then add back the gray one. For problem number 9, a little bit trickier, we're going to pretend, what you want to do is pretend that this part of the circle, the top half, is still included. So if we find the area of the gray part on the bottom plus this part up here, then we can just cut it in half to get just the bottom part. So what we need to do is find the area of the whole circle, and the radius here, we need this full distance. Well, from here to here is 5, because that's the radius here, and from here to here is also 5. So this distance has to be 10. We can use that to find the area of the whole circle. Then you're going to find the area of these 2 little circles, each one with a radius of 5. Subtract both of them from the whole big area, and that would give us this bottom little part and the top part. We only want the bottom part, so we'll take that final answer and cut it in half. Finally, problem number 10, it's important that it says that this is an equilateral triangle and the side lengths are each 7. That means that this half of it is 3.5. So what we need to do is we need to find the distance, we need to find this distance, but if it's an equilateral triangle, we just cut it in half, then we just created a 30, 60, 90 triangle. If this is a 30, 60, 90 triangle, then this side is 3.5, and down here, this half, and by looking at the hypotenuse, it's going to be the 7. And this height of it is 3.5 times the square root of 3, using the 30, 60, 90 shortcuts. You could also use SOHCAHTOA to find it, but I'll leave you to actually find that number. And now we know the base and height of this little triangle. Don't forget we're including this triangle, plus the one on the left also counts, so you'll need to double it when you find the area of this triangle. Then, if you add the 4 plus this measurement that you found, you'll have the diameter of the circle. Cut it in half to find the radius, and therefore the area of the entire circle. Then simply subtract the area of the circle, subtract the area of the triangle from the circle.